How's it going? I didn't see you over there. What was I doing, you ask? Did I raise your attention? I was welding. What is welding, you ask? Let me tell you about it. I have a speech prepared for you. Crazy. Now, if you stick around and listen to me, at the end of it, you'll be able to tell me and define what welding is on a fundamental atomic level, as well as tell me the major parts required for welding to happen, know about one major method of welding known as TIG welding, that's T-I-G. Note, this is not a how-to video. How many of us have a welder at home? This is just a broad explanation and definition of welding as a method. Now, why should you care? Look, our world is thanks to steel. Our modern world is thanks to steel. Look, this building is made of steel. Everything requires steel. Now, by understanding welding, which is a major process in manufacturing, you'll be able to know a little bit more about how your world is made and how it works. That's interesting. If you're a sciencey or craftsy person, this will be of special interest to you. Myself, I've been a welder and fabricator for over 4 years. I have a diploma from the state of France, and I'd like to share my experience that I got over the years with you guys. And so follow me to my lab. We'll go for an in-depth explanation. 2 pieces of steel and turning it into this. 1 single piece of steel. Note my weld where the 2 pieces of steel became 1 at their junction. According to Lincoln Electric, a major supplier of welding equipment, they define welding as taking 2 or more separate pieces of metal and joining them into one continuous or homogeneous section. I'm going to break that down, but I'd like to expand first. Not only metals are weldable, and not all metals are weldable. Glass and plastic, for example, are also weldable. To my surprise, even wood. Now, how does welding happen? How do they become one homogeneous section? This is through fusion. What is fusion? Fusion is when you reach the melting point of a material and it enters its liquid state. In its liquid state, like a soup if you will, the atoms are free to move around and form new bonds with each other. So if you have 2 different materials in their liquid state, their atoms can crisscross into each other, and when the material cools and it re-enters its solid state, the atoms solidify into one. So 2 different pieces and they now became one. Let me show you a quick diagram real quick. Alright, here you have the atomic structure of 2 different materials. Now let's imagine heat is being applied and they enter their liquid state, and here, cool down, they now solidified together into one. You see that they share their atomic structure. By atomic structure, I mean that the atoms form bonds now with each other. They're connected in one long chain. There is no difference between the 2. Homogeneous, meaning as one, like one. This piece of steel, for example, is now a single piece of steel. There is no difference between the 2, which differentiates it from gluing, for example, because now they're technically one. Okay, so how does welding occur? How do we enter this fusion state? Well, there are many ways of doing this, but primarily that's through heat. But according to the Tulsa Welding School, there are at least 67 processes welders can use to join metals. This is through different types of pressure, heat, and equipment that makes the difference. The most common method of applying heat to enter this fusion state is through an electric arc. I'll show you another drawing. This right here. So imagine you have your 2 pieces of metal right here. If you apply electricity coming from this electrode, which is where the electricity comes from, that's what it means, the orange zone is where there is entering its fusion point through the heat being applied. Now, right here, that is where the welding is occurring. 2 more things I haven't mentioned that are important, required for welding to occur, is oftentimes a filler metal, like this, is added. So if you were to look at the drawing again, in this orange zone, to fill in that space, that orange space, we add more metal. So you take 2 metals, and you basically put more metal in between it, on top of the heat. The last component that is required and essential is a form of shielding. By this I mean the atmosphere, the air I'm breathing right now, is actually corrosive to welding. It won't let welding happen if the air is on top of it. It's bad. So how we protect the weld from when it's happening, is by applying a shielding. Now, this is most often done through a gas that is not dangerous to welding, like argon, for example, a noble gas, and this protects the weld. Now, let's go back to the shop and I'll show you my welding machine, the TIG machine. Alright, now I'm going to show you one method and one tool that is used for this welding and fusion to occur. Now this right here is the torch of the TIG welder. The TIG welder, right behind me, and you can see in those bottles right there, the gas, that's where the gas is stocked. Right here is where the electricity comes out of this electrode, right here, and as well as the gas, which comes out of this cup. Now this is called TIG welding. TIG welding stands for tungsten, which is this, inert gas, which is what coming out of here, the protective gas. Now, Miller, which you might have seen on my helmet, is another large distributor of welding equipment, and they define it as a tungsten electrode heats the metal you are welding, and gas, most commonly argon, protects the weld puddle from airborne contaminants. Now, that's TIG welding, and that's what I was doing earlier. And you see here my weld I was doing with it. Now, if you were listening, as we've just discussed, you know and be able to define welding, the ways in which it occurs, what is required for it, and the basic concept behind TIG welding. Now you understand a bit more about the glue, except not quite, that holds our world together.